All right, hey guys. So I wanted to go over a couple of things. I had someone email me that they needed some help on the 3.3 section. So I wanted to make a little bit a video for you guys, just to kind of help with this. So let me pull up something for you guys. This is Zoom, and so I use this sometimes to make videos and stuff like that. So let's see. I'm trying to find the whiteboard. Share whiteboard. Here we go. Hopefully you guys can see all this. All right, so 3.3a is equations. And so when you have an equation, sorry, my handwriting is going to be kind of bad on this. So if you have something like sine of x equals to 1/2, you're trying to find x, and x is going to be a angle measure. So for all your equations, you should have an angle measure. Now let's say I want you to give me answers that are from 0 to 2 pi. That means that on the unit circle, I want the answers to be from 0 to 2 pi. Now if I don't give you that criteria, and on the examples in your videos, you probably saw like something plus an answer plus 2 pi k. That just means that your period on sine and cosine is 2 pi. And so you can come up with more answers by just plugging in a value into k. So you could use 1, you could use 2. So just adding a whole nother unit circle, or a whole 360, or a whole 2 pi to your answer. So what this means is you're looking at sine of theta and you want to find it where it's equal to 1/2. So if you remember, sine represents your y value on the unit circle. So think of y over r. We know r on the unit circle is 1. So if you go and look on your unit circle, where is y going to be equal to 1/2? Okay. And if you look at that, you'll see that y is equal to 1/2 at pi over 6, and also 5 pi over 6. So this would be your answer for this equation. And these answers are between 0 and 2 pi. Now let's say I wanted other answers. I wanted more. Let's say I wanted 6 possible answers. What you would do is you would take pi over 6, and I would add 2 pi to this, and then you can put in a value for k. So let's just use k as 1. So that's just going to be times 1. So you're saying, okay, pi over 6 plus 2 pi. Well, we know this is understood over a 1, right? So how do I get the same common denominator? I would multiply this whole thing by 6. So you would end up with 12 pi over 6 plus pi over 6. And what does that give us? That gives us 13 pi. Ooh, sorry. 13 pi over 6. Okay. All right, so you would do that again for 5 pi over 6. You would add 12 pi over 6, so that would be 17 pi over 6. So you could get a bunch of different answers. Then you could plug in k is 2, plug in k is -1, so you could get a numerous amount of possibility of answers. But for this right here, I'm just giving you an example of from 0 to 2 pi, okay? All right, now let's do another example. Let's say we have this problem. 2 cosine of x plus square root of 3. All right, again, we're solving for x. So what do we do first? How would I solve this? Well, we're going to move the square root of 3 first. Again, I want my answers to be between 0 and 2 pi. All right, so you end up with 2 cosine of x equals negative square root of 3. So then I'm going to divide by 2 on both sides. And so now I'm looking for some angle measure where the cosine of that is going to be equal to negative square root of 3 over 2. Remember, cosine is your x over r. We know r, again, is 1 for the unit circle. So pretty much I'm looking where your angle measure is going to be equal to where x is equal to negative square root of 3 over 2. So now go on your unit circle and we look for where x is equal to negative square root of 3 over 2. And you should be able to find that at 5 pi over 6 and 7 pi over 6. Okay, and again, if you wanted more answers, you could add a 2 pi to that. You could get 2 more answers. You could add a 4 pi to that and get 2 more answers. But that's all that means, okay? Let's do another example. All right, let's say you had an equation like this, secant squared of x minus 1 equals 0. All right, so I want to get x by itself. So the first thing I'm going to do is I'm going to add the 1. You're left with secant squared of x equals 1, sorry. Let's do an eraser. Okay, now how do I get rid of a square? We take the square root. And remember, anytime you take the square root, it's always going to be a plus or minus in front of that. So this should be the plus or minus square root of 1, which is 1. So now you have the secant of x equal to 1. So what that means is I'm going to have the secant of x equal to 1 and positive. Positive 1 and negative 1. And we know secant is your reciprocal of cosine, so that's your r over x. We know r is 1, so that means 1 over a positive 1 is your answer and 1 over a negative 1. So you're looking for an angle measure where your x is going to be equal to a 1 and x is equal to a negative 1. So now look on your unit circle sheet. You can see that it's at 0, or we also call that 2 pi. And then the negative 1 for the x value is going to be at pi. Okay, so these would be your answers for that problem. All right, so that's pretty much 3.3a. 3.3b is just proving identities. And so what the goal is for that is you're trying to prove that one side of the equation is equal to the other side. And I'm going to do an example for you guys of that. And so that's pretty much just using all your identities to prove these. And the suggestion for this is to always change everything to sine and cosine. I think that's what your online Mat-172-50 uses, is they change everything to that. So I'm just going to give you a couple examples of this, and then hopefully that will help you guys a little bit more. So let's prove secant of x minus tangent of x times sine of x. Prove that it's equal to 1 over secant. And so we always only work on one side of the equation. So I'm going to work on this side. And so what I'm going to do is I'm going to change everything to sine and cosine. So this one's already sine. I know there's a reciprocal, there's an identity for this. Tangent of x is the same thing as sine over cosine. So I'm going to change this to sine of x over cosine times sine. And then I know secant is the same thing as 1 over cosine, right? So sine times sine is going to be sine squared, okay? So this becomes sine squared of x over cosine. And I have this, all right, I forgot to put my x there. And we have a common denominator here already, so I don't have to do anything else. So I end up with 1 minus sine squared of x over cosine of x. And then think about this right here. What is this the same thing as? Well, 1 minus sine squared, think about your identity. What identity uses a 1 and a sine squared? Well, there's the Pythagorean identity, which says sine squared of theta, sine of squared of x, plus cosine squared of x is equal to 1. So I did 1 minus sine squared. If you move this over here, that's going to be equal to cosine squared. So I end up with cosine squared of x over cosine. And if you have a cosine squared over a cosine, you end up with just a cosine, right? And then I know that cosine of x is the same thing as 1 over secant. So I just proved this identity. Some of you guys will have different ways of doing this, but as long as you get that this side is ending up equal to this side, then you have proved the identity, okay? There's a million of these online. If you just go to Proving Identities online on Khan Academy, you can find a bunch more of these. You just need to practice them. You know your identities. And that is about it. Email me if you have any questions. Thanks.